Good afternoon to all. It's my voice is clear?
Yes, sir. It is clear.
Audible.
Yes, sir. Thank you. So it's my immense pleasure to welcome you all on behalf of IIF Chennai Chapter. I'll invite all the participants and Mr. Vivek Pol for a webinar on effective and efficient way of metal stream inoculation. So the thing started. I will introduce today's speaker, Mr. Vivek Pol. So he is basically a BE metallurgist. He completed his metallurgy in 2005. He started his career as an application engineer in Foseco India Private Limited, worked on Initech project, Foseco patented process for ductile iron production. Then the solution manager for ferrous metal treatment, dealing with products like inoculants, ferrous ignition magnesium alloys, furnace and ladle scavenging fluxes for iron and steel, slag coagulation for iron and steel. Then the solution manager for Foundry Melt Shop, dealing with advanced refractory products for iron and steel, flow control products for iron and steel, and products in ferrous metal treatment. Totally, he has 17 years of experience, out of which 4.5 years of work experience in iron foundry. Very experienced person. Now the floor is yours, Mr. Vivek. Thank you.
Yes, sir. Thank you for your brief introduction. I will share. I have already shared the screen. Let me know if presentation is visible.
Presentation is yes, sir. Yes, presentation is visible, sir. We can start, sir. Thank you.
Yeah. So as the topic is already introduced, which is an effective and efficient way of metal stream inoculation. Before we jump into the topic, we can cover some basics of inoculation, and then what are the different ways that we can inoculate the iron, and then finally a question and answer session. So along with me, Mr. Santosh Bhagwat is also have joined this call, and he is basically a process control engineer looking after equipment part. So I welcome and thanks to Santosh for joining this meeting. So as we Foundrymen knows that though we are producing castings, but when we are actually selling dimensions and properties, means customer is interested in the right dimensions and the right properties. So dimensions part is taken care by mold and core systems, whereas properties, whether it's metallurgical, mechanical, microstructural, all are they are based on the metallurgy of that particular iron. So when it comes to the properties, to meet the right properties repeatedly, we need a strong or robust process control, or the processes in the foundry should be very effective and very efficient. Then only we can expect the desired properties. So these processes, we know there are n number of variables in foundries. So there is a obvious process variation is there. So for any process needs to be robust. We need to measure it, and we need to stabilize it, and also we need to predict what can go wrong and all, and once we can predict, then we can correct it also. So first step is it should be measurable, and for stability and predictability, yes, there are Foseco can help in different offering of different products, innovative products, as well as the service support, which can help foundries to stabilize the process. So coming back to this main process part, which actually means the properties, I mean to say the properties which actually coming from the microstructure of the casting. If microstructure of the casting is not okay, then definitely our properties will also not okay. So for having a desired or expected structure, there are 4 levers. One is base iron. Whatever metal we are preparing in the furnace, we call it as a base iron. So the if the quality of base iron is not consistent, then definitely that variation will continue to the pouring, and ultimately your microstructure will also affects. Second is periodizing. This is basically for SGRN treatment. So periodizing is another lever which can affect the microstructure. Third one is inoculation, another very important step. If inoculation is not adequate, then definitely your structure will be disturbed and you will not get the desired properties. And finally, the cooling rate. So cooling rate also plays very important role. So casting knockout, how much time we should give for casting knockout, that also determines the microstructure part of it. So this is how I try to capture here the iron. This is for gray iron, this is for AG iron. You can see from liquid to solid during this transformation how the structure is taking place, like from a very initial nuclei point to final flake graphite in case of gray iron, and nodular graphite in case of SG iron. So basically uh, here, if inoculation for gray iron, inoculation is playing very important role for desired graphite morphology, type A predominantly. In case of SG iron, apart from the very good magnesium treatment, very consistent and with high recovery magnesium treatment, support of inoculation is required, which can improve the microstructure. For in case of AG iron, microstructure in terms of its nodule count, nodularity. So this is being driven by the good choice and good way of inoculation. So basically inoculation performance or response is depend on major these by and large these 3 aspects: melt, application, and inoculant itself. Melt means as the base iron chemical composition, the way we are charging, the way we are holding the metal. So that all decides how much or which type of inoculation we should use and how inoculin will perform. So in detail we can see in further slides. Apart from melt, application is another aspect which is playing very important role. How we are doing this inoculation, like there are various methods: ladder stream, lead stream, in mole inoculation. And inoculation itself means what type of inoculation we are using for that particular iron, means it is based on our final aim, which is properties. So to achieve the desired properties, which type of inoculation we should use, that is also playing important role. So we'll see what is inoculation, how it works, and why we should inoculate, and when it should be, when we should inoculate or when we should not. Inoculation is basically a late addition of silicon alloys to the iron. And why we are doing this? Just to change the structure and properties. Means first microstructure will change, it will modify or it will get improved, and then because of that our mechanical properties, metallurgical properties will improve. So graphite distribution improves, predominantly A-type graphite in case of gray iron. Mechanical properties is, these properties are depends on the microstructure. That's why if microstructure improves, these mechanical properties also improves. chilling tendency will reduce, and it assures solidification in the austenite graphite system, like in gray solidification. So it is free from chilling tendency. Then how inoculation works? So you can see this is one part of the iron carbon equilibrium diagram. Here you can see this is graphitic line and this is carbonic line, and the role of different alloying elements in this, you can see the elements like chromium, vanadium, moly, manganese, which are increasing this carbonic line and decreasing this graphitic line. So what is the significance of these two lines? That also we will see in next slide. On the other hand, the other elements like silicon, phosphorus, aluminum, copper, nickel have reverse effect or impact as compared to these carbide formers. So these elements will pull graphite line up and this carbonic line down. So basically what we need is all our iron should get solidified just below this graphitic line. As you can see on this is thermal analysis curve, this temperature versus time, and you can see this is carbonic line, gray line, and this is this is graphitic line and this is carbonic line. So the more solidification happens close to this line, the undercooling will be more and graphite structure will be like not desirable. So our aim is to solidify as close to this line. This line means carbonic, above carbonic and just below the graphitic line. So basically inoculation helps iron to solidify in this area near to carbonic line, so that our microstructure get the means we get the desired microstructure. Like how cooling rate is having impact. So for fast cooling, if inoculation is not adequate, then we can see this is the solidification segment, you can say, and here it is below this line means below carbonic line. That means your all iron will solidify as a carbide chilled. Whereas with good amount of inoculation, the iron will solidify near to graphitic line. The same way for slow cooling. Here type of different graphites. So for this type of solidification, we will get predominantly A-type graphite. Undercooling means the way undercooling is more, you will get this type of graphite, which is called type B rosette type structure. This small flakes is because of the low nucleation level. This type C, also known as quiche graphite, because of the high carbon equivalent, means iron with high carbon equivalent, and maybe with use of very high additions of inoculation, this type of graphite structure we will get. And the other two like D and E, again this is because of the undercooling, too much undercooling, and that's why this D and E, which is definitely not desirable microstructure that we can get, only because inoculation is not proper. In case of HJRN, you can see uninoculated iron HJRN is showing some of these carbides, and the nodule count is low compared to inoculated iron. So you can see this, the very evident difference between inoculated and uninoculated HJRN. So basically, it established use of inoculation, establish nucleation centers for graphite precipitation. So it is doing, we are doing inoculation means we are creating nucleation sites. On those sites, graphite will precipitate, grow, and from, in case of gray iron, it will form eutectic cells, and in HJRN it will form nodules. So this is how the graphite structure is getting controlled. As also matrix structure like ferrite pearlite ratio and zero carbides. So by achieving this graphite structure as well as matrix, overall the improvement in mechanical properties, then reduction or elimination in chill, and at the end machining properties of the iron also improves. So when inoculation is desirable, like in case of high strength low carbon low C value gray iron, so where carbon and silicon are on lower side, maybe like FG 300, like that composition where carbon equivalent comparatively on lower side, and there are the other applications also where C value is on lower side, and then in and low C means those metal are prone to shrinkage as well as the uh, carbide tendency of that metal is higher. So for that type of composition we need inoculation and adequate inoculation. In case of HJRN, after magnesium treatment, we know that during magnesium treatment, a lot of violence is taking place, and because of that reaction violence, the nucleation level in the metal get lost. That's why to regain that nucleation level, we need to do inoculation. In case of electric melting, which is very rare in nowadays, but uh, the output in electric melting is with very low nucleation level. So basically, as we have seen that inoculation main role is to create nucleation sites. So wherever there is low nuclei, we need more inoculation. For example, if metal is getting hold in holding furnaces or automatic pouring furnaces, there also we need more inoculation. Also, in case of the variety of charge mix, if any foundry want to use like low cost charge mix, maybe borings or some scrap where nucleation, where some because of the oxidation or basically the oxidized scrap, which is cheaper than the clean and the clean scrap. So for those type of scrap, the inherent nucleation level of the base metal is very low. So that time we need high inoculation. Then this more flexible scheduling pouring means if metal is getting hold in the furnace, for, for, for those events we need inoculation. The same what we have discussed in case of means when we need more inoculation in case of low carbon equivalent, if sulfur values are lower, high alloying elements which are mainly like carbide formers, compared to these where need less inoculation like high carbon equivalent, then low alloying elements. If melting is through cupola, then inherently inoculation level is high, nucleation level is high. That's why we need less inoculation. Also, the casting which are solidifying, like the slow cooling casting needs less inoculation, whereas fast cooling casting or thin wall casting needs more inoculation. like ladle or stream. So if we are using only ladle inoculation, that means we need it more, because we are adding it a bit early. And whereas in case of stream inoculation, it is just before pouring. That's why the addition rate is also on lower side. So these are different methods of inoculation. Populars are ladle and lead stream. In ladle, these uh, grains basically, which is very popular in Indian foundries. In case of late inoculation, in mole inoculation or in stream inoculation is very much popular. Okay, then how much inoculation we should add? The lowest possible amount is what desired, is recommended. Why lowest possible? Because adding anything on into the liquid metal before pouring is nothing but we are actually adding inclusions. That's why uh, we should add means as less as possible, but we should that should be effective, or that should be adequate enough to take care of our for desired properties and desired microstructure. Then size depend on where we are adding. So, and when means when we should add, so as late as possible. So this means the late stream inoculation with MSI machine is the ideal solution. So Poseco's MSI machine, means metal stream inoculation machine, considers all these aspects, like no, it understand why, means which inoculation, when to be add, how to be add. So considering all these aspects, we have designed this MSI machine, and which is taking care of your metal quality. So this is this is how MSI machine looks. You can see uh, this stream on metal stream inoculation is added, and just before the pouring. That's why and uh, this is the very effective way of inoculation, because this is in this way it will get melted easily in the metal stream, and that's why we need it in very small amount. So again the again question arise, like if foundry processes are measurable, stable and predictable, then MSI machine and use of inoculant which are specifically designed for the MSI machine needs to be used. So where we can use MSI machines? So iron foundry is basically divided in iron mass or mass iron foundries and jobbing foundries. So for mass iron foundries it is uh, applicable, I would say, because we need a fixed pouring station or fixed molding line uh, for MSI installation. So for mass iron foundries, the challenges what we understand is getting consistent metallurgical and mechanical properties in the casting. Like in mass iron foundries, continuous production is going on, and any small variation will uh, affect the casting properties. And no, if one of the heat goes wrong, and if we didn't track that heat, then entire casting lot we need to be rejected. So that's why it is very crucial to get the casting properties every time right. So, and inoculation, since it is playing very important role, so to understand how our casting is getting inoculated, how our metal is getting inoculated is important. And that's why currently various foundries are using various types of inoculation grades and conventional machines to ensure that inoculation is happening. And the challenges with these conventional type of machines is like these are basically screw feeders, and the way they are designed is not ensuring the right amount of dosing of inoculant. So sometimes over inoculation will happen, and sometimes under inoculation also. So with both these over and under inoculation, both these scenarios are not good for the for getting the right microstructure, and that's why also these machines are not able to tell us means live data, like every mold is getting inoculation, means whatever inoculation we have set is that means is that inoculation is actually going into the mold, that the amount which we have decided, the amount which we have set for the machine, there is no control. Some of the machines screw feeders, and this is one small video where you can, I'm not sure if you could see the lot of wastage of inoculation is happening because it is not hitting the small pouring basin. In case of dysametric line, the space is a constraint, and for that the stream of inoculation should hit the stream of the metal in that very narrow area. So here you can see some wastage, around 20-30% inoculation is just on the molds. It is not getting into the metal, and that is the under inoculation scenario. So Foseco MSI machine is, as it states, a consistent and robust inoculant dispensing system along with the variety of metal stream inoculants which are specially designed to flow through MSI system, ensures every mold is getting inoculated accurately at optimized addition rate, delivering consistent casting quality mold after mold. So basically, mold after, speed of mold moving in mass and foundries. So like sometimes after every 30-second mold is moving, and every time every mold is inoculated properly or not, that assurance is very challenging. So MSI type of machines are designed for that purpose only, that it will ensure every mold is getting inoculated, not just inoculated, whatever we have decided or whatever we have desired, the addition rate and all, with it will deliver the consistent output. And when it is consistent, means your casting results will also consistent. So some introduction, like when it has developed, MSI machine was first developed in 1972. After that, some R&D work, after some R&D work, and it has evolved further, and the current machine which we can see is consisting of this 4 components: control unit, cabling, hopper, hot box. You can see the control unit. It is latest version which is evolved based on the customers' reviews and their suggestions. So it is like computer itself. We can see how it is working. The different, this is the hot box which is having capacity to store up to 30 kg of inoculant. So maybe all these details no need to know, only the capacity of this hot box is actually placed very near to the pouring area, I would say. In case of press pour, it is just near to the stopper. Control unit which needs to be placed in the protected environment, like in a inside cabin. So you can see the demo video here. This is live data. It is as good as computer. You can see on what date at what time what what was the desired or set addition rate and what was actual total time for inoculation flow. Everything you can see here. So in terms of features and benefits, it ensures accuracy in inoculation dosing, mold after mold, and the machine itself is designed on the premise that metal inoculation is an engineering operation. So, uh, so that's why the machine is designed very carefully and considering foundry environment, equipped with comprehensive monitoring facility, giving early warning of low inoculation level in the hopper or system malfunction. Easy, quick, and flexible adjustment of inoculant addition as per the molding program to avoid under or over inoculation events. So just when pattern change, you just need to input the your inoculation addition rate into this control panel, and it will adjust very quickly and will start delivering that addition rate. So every inoculation event is recorded, so it is a live recording actually. So, and whenever you want, we can connect the memory stick or pen drive and we can retrieve the data. So this is very useful function from audit point of view. So we can face auditor very confidently that from inoculation side, I'm very I can ensure that my every mold or my every casting is inoculated in rightly. So if any other issue is there, we can focus on that. But the variable from inoculation side is address. Easy and infrequent calibration for accurate inoculant doses. So if 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 you follow some basic disciplines, there is no need of no frequent calibrations. So calibration like once in a 3 months, once in a 6 months is also okay. And no, means this machine and the material which is inoculant going through this machine. These are designed design with means by understanding there, like while designing inoculant we have means every inoculant is tested through MSI machine only. So means any inoculant will not go as effective as Foseco's inoculant through Foseco's MSI machine. That's why we always recommend use of Foseco's material when you are using Foseco's MSI machine, because the products are designed based on the features and the working principle of MSI machine. So this is overview of the main screen. You can see there are different selections. These are maybe so like for calibration. We need to select this tab. Then for process data view, this is the flow rate in gram per second. So very flexible. You can give input of any flow rate as per the casting requirement. Then these logging inoculation cycles. This is a live data. Every mold is getting recorded here. some other safety features, locking, unlocking, display for the operation modes and the error status. The different modes are there, that also we can see in the subsequent slides, and keyboard for entering parameters. So very easy to operate this machine. So everything is very clearly defined, and some features which are related to the process control, like this flow rate and consistency in flow rate is based on the motor position, that which is showing here. Then this actual flow rate, and this is measured flow rate, means this is the set value and this is the uh, actual which is measured by the machine. Temperature of hot box, actual for hot time inoculation is flowing, and other parameters. These are mainly related with the engineering part of the machine. So maybe operator no need to look into this on day-to-day basis. Some you can see there are some failure warnings, like if and the beauty of this machine is when these faults comes, your production line will stop. And this is why this is very good feature, because machine will not allow any mold to go without inoculation, without, or if it is lower than, means significantly lower than what we have decided to add. So that means you are not even a single casting will pass without inoculation. That's why we can say it is a very strong process control tool. Some, like because of pipe blockage, inoculation is not flowing, then also it will give the alarm. Pressure is low, if any error related to motor, error related to slide gate. So whatever error which can result in low flow of inoculation will give this malfunction error, and let the operator know that something wrong and needs to be taken care. And operator even cannot ignore these warnings, because it is linked with the machines, pouring machines, and that's why pouring machine will not operate. So again, this video, this is live video. When inoculation flows, then this green light is on, and you can see this, and you can operate manually as well as in auto mode. So there are a lot of facilities available with these machines. So what are the advantages over screw feeder machines? So accuracy level and consistency in flow rate is maximum. Inoculation falls under gravity and no crushing and or rubbing of the particles. In case of screw feeder, maybe you know that it is like it is a screw which is moving and which is taking away the based on the RPM value, the addition of means the inoculation flow is happening. It is not based on the like what MSI machine offers. And because of this in screw feeder, because of the movement of screw, the crushing and rubbing of inoculant particles takes place, which results in fines generation, and overall the wastage is more. Online inoculation data, we have seen the live data is very visible and we can retrieve at any point of time with the MSI machine. So mistake proofing, warning and malfunctioning. So even operator cannot ignore that inoculation is not flowing, and the machine will entire means line will stop. That's why it is mistake grouping, and thus it ensures your castings are means getting inoculated, and this is another very important function. The maintenance requirement, if the proper basic disciplines are taken care, then it is maintenance free, visible and easily understood operating parameters. So operator friendly, we can say. So these warnings and malfunctioning messages also very like very distinct, means where no need to interpret those messages, very easy to understand. Service backup is always there, so we have a dedicated team like Santosh in this hall, who is dedicated for taking care of service part of this type of machines. So like frequent calibrations or frequent replacement of any parts is not required for MSI machine. So with respect to applicability, we have seen in case of means mass and foundries where continuous castings are produced, and basically the pouring or the molding lines are fixed. So there on those lines, this machine we can install like press pour, unheated turn dish, fixed pouring ladders, or pouring ladders with moving track. So those are things, and some of the prerequisites, we can say. These are some very basic. You can see these automatic pouring machines like unheated turn dish, press pour, this type of ladders where there is some space where we can install the machines. As a way forward, based on the process mapping, we identify the need for MSI machine. Then, after decision is made, some prerequisite type like the continuous power supply is required for control panel, because it is like computer. We need clean air. That means the air which is acting as which is the input to MSI machine uh, should be free from oil and moisture. And once all is done, then Foseco will install the machine, and basically the business model is Foseco is not selling this equipment. We install it on a cost basis, and against that, whatever inoculation we are using or going through the MSI machine, that should be used, that should be buy from Foseco. And the only reason is the machine and inoculation, they are compatible to each other. So we have designed inoculants which are working with the MSI machine. So that is how it is. We can say the way of efficient and effective way of metal stream inoculation. So if any questions, we can discuss. No questions?
Sir, good afternoon. I'm Venkappa here
Yes,
from
sir, good
Vijay
afternoon.
Technat Shumoga. See, the stream inoculation, will it be suitable only for high pressure molding line? Can we use this for our manual machine molding also, where hydraulic push-pull system is there.
Means pouring is manually through ladles.
Manual through ladles. Underslung crane is there. Through that we are feeding the metal.
Yes.
Will it be possible to incorporate this inoculation?
Yeah. Actually, we can use stream inoculation, but the way of using the application part is challenging because it is totally manual. Some person needs to present all the time to ensure that every mold means manually it is getting inoculated. So addition rate and assurance for that is challenging.
No, sir, our foundry is in Shimoga. Can you please depute who is the person responsible for implementation of this item, this product?
For machine installation, our Santosh Bhagwat, who is in this call, he is responsible.
Santosh is known to us. So please ask him to visit Shimoga, sir. We will first let him see the layout. Shantala, Vijay, we have not high pressure molding line. So we let it be little semi-automatic so that the benefit can be reaped out. Instead of doing manual inoculation, this machine can give exact input to the pouring mold. So this is our request, sir.
Yes, sir. Yes, thank you for that, and definitely will Santosh will definitely make a visit, and we'll see to it, sir.
Right, sir. Thank you.
Any further questions, gentlemen? So if there are no further questions, we'd like to proceed with the vote of thanks. So gentlemen, we have had a very interesting webinar today on the topic Metal Stream Inoculation. So we are sure the contents of the talk had a lot of takeaway for our audience. We'd like to thank our speaker for the day, Mr. Vivek Pol, Solutions Manager, Foundry Melt Shop, Fusiko, for taking time off his busy schedule and making us rich with knowledge. Further, we'd like to thank all the members who joined us for this talk. I'm sure you had a wonderful learning experience, and thanks for being such a wonderful audience. We from Chennai Chapter will be conducting many such interesting programs, both physical and virtual, and we'll be sharing information with you soon. Looking forward to seeing you in upcoming programs. Thank you very much.
Thank you, Vignesh sir.
Thank you, Vivek sir. Thank you so much.
Thank you.
Yeah.
Thank you all.
Thank you so much.